Welcome to this explainer. Today we're going to do something pretty cool. We're taking the seemingly invisible world of database management systems and pulling back the curtain, going on a journey from conceptual blueprints all the way to physical reality. It's time to look under the hood and figure out exactly how the massive amounts of data we interact with every single day are structured, organized, and deployed behind the scenes.
Here is our quick roadmap for today. First, we'll be unpacking data models. Second, 3 ways to organize them. Third, schema versus instance. And finally, the 3-level architecture. All right, let's jump right into section 1, unpacking data models. So before you can even think about storing a single byte of information, you need a master plan, right? And a data model is exactly that. It's a collection of concepts used to describe the actual structure of a database, the relationships among the data, and the specific constraints placed on that data. You can kind of think of it like the architectural style of a new building. You have to set the ground rules and figure out where the load-bearing walls are going to go before a single brick is laid.
Now, you might be wondering, why does this master plan even matter? Well, a solid data model is absolutely crucial because it organizes your data efficiently and clearly defines all those complex relationships. But maybe the biggest win here is that it reduces data redundancy, meaning it cuts down on unnecessary space-wasting duplication. The end result is just a much stronger, highly reliable database design across the board.
Moving right along to section 2, 3 ways to organize. Our first approach is the hierarchical data model. This one organizes data in a strict tree-like structure, honestly very much like a traditional family tree. So a single parent record branches out into multiple child records. But, and this is the golden rule you have to remember here, each child has only one parent. Because of this simplicity, it's incredibly easy to understand and provides super fast directional data access.
Now, if the hierarchical model is a strict family tree, the network data model is more like a massive, tangled web. It steps up the complexity by allowing records to have multiple parent and child relationships. By supporting these many-to-many relationships, it gives you way more dynamic flexibility, which is exactly what you need for highly complex, interconnected databases.
But that brings us to a pretty massive question, one that basically defines almost all of modern software. Which model actually stores data in those familiar tables you're probably picturing in your head right now?
The answer is the relational data model. This is without a doubt the undisputed champion of the modern digital world. By storing data in highly intuitive tables made up of rows and columns, it makes managing, retrieving, and updating your information amazingly easy. It's literally the engine behind most of the systems we use today.
Let's shift gears a bit for section 3, schema versus instance.
To really understand how a database works in the wild, we first have to look at the database schema. This is the logical structure or the design of the database. Going back to our building analogy from earlier, the schema is the unchanging floor plan. It dictates exactly where the rooms and hallways are, but it tells you absolutely nothing about who is actually walking through those rooms today. By contrast, the database instance is exactly who is in those rooms right now. An instance is the actual live data stored in the database at a very specific point in time. It's a real-time snapshot of the breathing reality occupying that structure right at this exact second. When you weigh them side by side, the distinction is crystal clear. The schema is the logical design, and it rarely changes. I mean, you don't tear down the foundational walls of your database every Tuesday, right? The instance, however, is the actual data, and it changes frequently, constantly morphing and updating with every single new piece of information that gets entered into the system. Which brings us to our final stop, section 4, the 3-level architecture.
We can actually break down how a single database is viewed into 3 distinct steps. Moving from the outside user interface all the way down to the physical hard drive, we have the external level, the conceptual level, and the internal level.
Right at the top sits the external level. This is what you and I see when we open an app. It's the user's view. And what makes this level brilliant is how customizable it is. Different users can have totally different views based on their permissions, while all of that overwhelming, chaotic complexity underneath stays completely hidden. Digging one layer deeper, we hit the conceptual level. This is basically the master map for the database administrators. It describes the complete logical structure of the database, defining all the tables, the relationships, and the constraints, neatly weaving all those different external views into one unified logical picture. Finally, at the very bottom is the internal level. Here, we're dealing with the absolute nitty-gritty.
This level dictates how the data is actually physically stored on the hardware. We're talking file organization, specific storage details, the complex machinery that the end user up at the external level never even knows exists.
So let's do a super quick recap to lock all this in. We've explored the foundational data models, whether that's a hierarchical tree, a flexible network, or your standard relational tables. And we've seen how that data is viewed through three distinct architectural lenses: the user-facing external, the logical conceptual, and the physical internal level.
I want to leave you with this thought to ponder. Considering how radically different a clean, highly customized external view is from the raw physical internal storage, how much digital chaos do you think is beautifully and seamlessly hidden behind the simple apps you use every single day? It certainly gives you a whole new appreciation for the invisible blueprints holding our digital world together. Thanks so much for joining this explainer, and keep questioning how your world is built.